So welcome to this session, and here we will be learning about vectors in linear algebra. So a lot of terms which you know about vectors such as dot product, cross product, you will learn in the context of linear algebra and a little more as well. So let's start. A vector is an ordered list of numbers, so you can write it as like this: 1 minus 2. This is a two-dimensional vector and this is a three-dimensional vector. These are row vectors. They are written in a single horizontal row. Vectors are enclosed in square brackets or round brackets, so you have to use only square brackets or round brackets. Now if I write v equal to cos t sin t t, this is a vector function. And if I write it like this vertically, it is a column vector. And by convention, vectors are usually in column orientation. So you need to remember this, that in general, vectors are in column orientation. Now, you know that transpose of the row vector is the column vector, and two transposes of the row vector will give you back the same row vector. By convention, v is a column vector, so v transpose will be a row vector. Now coming to vector addition, if this is 1 and 2, this is 1 plus 2, this is a triangle law of addition. So remember, addition is from tail to tail to head. And subtraction will be, this is v1 and v2, this is v1 minus v2. So subtraction is from head to head. Note that vector addition and subtraction are possible only when both vectors have the same dimension. So you can add only a two-dimensional and a two-dimensional vector, or a three-dimensional and a three-dimensional vector. You cannot add a three-dimensional vector to a four-dimensional vector. Now, multiplying a scalar lambda by a vector v means to stretch or shrink the vector. Lambda greater than 1 means the resulting vector will be longer than the original, and lambda lies between 0 and 1 means the resulting vector will be shorter. So lambda v we can write as lambda v1, lambda v2, lambda vn transpose. And if v1 is abcd, v2 is abc, xyzw, 4 into v1 minus 2 into v2, note that asterisk stands for multiplication. It will be 4a, 4b, 4c, 4d, minus 2x, 2y, 2z, 2w, that is 4a minus 2x, 4b minus 2y, 4c minus 2z, 4d minus 2w. Coming to dot product, a dot b is denoted by this symbol in this type of bracket, and this is given by a transpose b, which is the a is the row vector and b is the column vector. So summation I taking value 1 to n ai bi. So if you have to multiply the dot product, you just add the corresponding entries: 1 into 5 plus 2 into 6 plus 3 into 4 plus 4 into 8. And what is this equal to? When you simplify, you get it as 70. Now, a into a is norm a squared, and it is denoted by norm a squared. If I just put the square, it becomes norm a squared, otherwise it is just norm of a, and norm a squared is a transpose into a, which is summation I taking value 1 to n ai squared. So if v1 is 2547, v2 is 4168. Now coming to dot product is denoted by dp or dot v1 v2, and that will be just you multiply the corresponding entries. Again, Cauchy-Schwarz inequality is modulus of v transpose into w less than or equal to norm of v into norm of w, because norm of v is same as norm of v transpose. So we can write it as equal to norm of v into norm of w into cos theta, where theta is the angle between v and w. So this is the Cauchy-Schwarz inequality and this is the dot product. Now if w equal to lambda 1 v1 plus lambda 2 v2 plus lambda n vn, this is a linear weighted combination of vectors v1, v2, vn. Again, if v is an m by n column vector, w is an n by n 1 column vector, outer product is defined by vw transpose. This will be an m by n matrix. Now coming to Hadamard Vector Product, here we multiply each corresponding element in the two vectors. This is again defined only for two vectors which have the same number of elements, and it is denoted by this symbol, the Hadamard Vector Product. So this is a1, b1, a2, b2, an, bn. It's an n-dimensional vector. whereas for dot product it is a scalar. So if you do this column vector Hadamard vector product with this will be 5, 12, 21 and 32. Coming to cross product, you have already learnt in vectors. If you are given cross product of a1i plus a2j plus a3k, b1i plus b2j plus b3k, that is I times a2b3 minus b2a3 minus j times a1b3 minus b1a3 plus k times a1b2 minus a2b1. So the cross product you can write it column wise as a2b3 minus a3b2, a1b3, when you take the negative it becomes a3b1 minus a1b3 and a1b2 minus a2b1. Again, unit vector is a vector with norm of v equal to 1. And how do you create a unit vector? Divide v by the norm. So v by norm v becomes a unit vector. Coming to a few problems now, calculate the dot product of these two vectors. Note that the dot product is a scalar, so this is AC plus BD. Again, compute the angle theta between these two vectors. So this will be, you're writing V transpose W. So write this as a row vector and this as a column vector. So theta will be dot product of this, that is 10 into 2.5, 25 plus 36 plus 4 into 1, 4 by root of the norm, because V transpose W is norm of V, norm W, cos theta. So what is cos theta? V transpose W divided by norm V, norm W. So when you simplify you get it as 1. So cos theta is 1 means theta is 0. Okay, next compute the outer product of this. The outer product of two vectors will be this multiplied by transpose, VW transpose. So this remains as it is and multiplied by 0, 1, 3 in a row form. This is a 3 by 1 matrix. This is a 1 by 3 matrix. So the product will be a 3 by 3 matrix, that is 0, minus 1, minus 3. Then 0, 3 into 1, 3, 3 into 3, 9, 0, 0 into 1, 0, 0 into 3, 0. Because outer product of V1, V2 is V1, V2 transpose. Again, determine whether this is a unit vector. So 0.2 squared plus 0.64 squared plus 0.1 squared plus 0.4 squared. This will give you 0.6196 because it is not a unit vector. Why is that? Because if it has to be a unit vector, the norm has to be 1. Again, find the magnitude of mu V, where mu is norm V. So mu V will be norm V into V. To find the magnitude, what do? We take the norm. So norm mu V is norm V into norm V, that is norm V squared. So the magnitude is norm V squared. So we have learnt a few basic terminology of vectors in linear algebra, the triangle law of addition and subtraction, dot product, cross product, Hadamard vector product and outer product. So thank you.